Okay, so let's talk about the zeros of a function a little more. Once again, the zeros of a function are the x-intercepts. In other words, where the function has a value of 0, where y is 0. Okay, so, ooh, that's fun. Okay, now we're talking not just about any x-intercepts, but the rational ones. Rational numbers are numbers that can be written as ratios, okay, where the top and bottom of the ratio of the fraction are integers. So things like 2/3 or -3 halves or 7/9 or 4/1, which is just 4. Those are rational numbers. Okay, so there's this thing called the rational roots theorem, or rational zeros theorem, however you want to call it. And it is designed to help you find them all. Unfortunately, it's a slight bit of a process. It's not bad, but the math involved is very simple. Okay, so here's what you have to do. First of all, you build a list of numbers that we will call our P numbers. Why P? That's just usually what they use in textbooks. Now, the P numbers are going to be all the numbers that divide into the constant term of the function, the term that has no x. Well, 1 divides in 3 and 9. Okay, cool. Now we need to find the Q numbers. And the Q numbers are on the other end. They're the numbers that divide into the leading coefficient. The coefficient corresponding to the highest power of x. So 4. Well, that'd be 1, 2, and 4. Cool. All right, now we use those together to find our P over, whoops, I didn't draw that very well, our P over Q numbers. Okay, so our P over Q numbers are going to be all combinations of these guys divided by these guys. All right, so, and you can do it any order you want. I'll just say, I'll take 1 and divide it by each of these. Then I'll take 3 and divide it by each of these. Then 9 and divide it by each of these. Just kind of keep some kind of order so I know where I'm at. All right, so 1 over 1 is 1. 1 over 2 is a half. 1 over 4 is a quarter. All right. Clearly, the math involved is not super challenging, and that's cool. All right, so we took care of that guy. All right, so 3 over 1 is 3. 3 over 2, 3 halves. 3 over 4 is 3 over 4, 3 quarters. Cool. All right, so that guy's done. 9 over 1, 9. 9 over 2, 9 halves. 9 over 4, 9 fourths. Okay, so we have taken care of all combinations. Now, often when you do this, it wasn't the case on this problem, but often some of these numbers here are going to be repeats. You don't need to write them out a second time. That won't help you. You can if you want, but just skip them when you got repeats. Okay, now, it turns out that, we're looking for all combinations of P over Q. Now, the numbers that divide into 9 gave us these, but it's really not just 1, 3, 9. It's also -1, -3, and -9. And the same thing with these guys here. It should be -1, -2, -4 as well. So what we'll do at this point is we'll just say, all right, the positive and the negative version of each number. We could have done that at the beginning, but this is fine. I think it's slightly easier. Okay, so we've got this super cool list of numbers here, our P over Q numbers. Those are, that's the list from which all rational zeros for the function are found. They're found in that list. If there are any rational zeros, and there might not be any, if there are any, they are on this list right here. See, I knew there'd be a use for me goofing around with that. Okay. Now, we know that there are only four roots at most. So, rational roots, irrational, whatever. So, most of these are not going to work. Okay, probably just, I don't know, probably two of them. There's a reason for that, but no point in getting into it right now. Okay, so we need to plug each of these numbers. There's 2, 4, 6, 8, 10, 12, 14, 16, 18. We need to plug each of those 18 numbers into the function, plug them in for x, okay, and see if they are zeros of the function. See if they make the function, the y, equal to 0. We could do that by hand, but doggone it, I really am not interested in doing that. And I think we're probably going to be in agreement. So let's use the calculator. So let's plug our function into the calculator. So 4, -8, -8. Okay, so we're going to go here. 4x to the 4th minus 8x to the 3 minus 8x squared. Let's see, am I doing this correctly so far? Yes, the minus 6x minus 9. Okay, where's the cursor? There it is. Okay. All right, so there's my function. Now I want to plug in these very specific values. So instead of just going straight to the table, I'm going to go second window. I'll pick ask. Then I can plug in exactly what I want. And again, most of these aren't going to work. All right, and we're looking for where they're supposed to be zeros of the function. Make the function or y equals 0. All right, so here we go. How about, I'm going to start over here with +1. So 1, nope. How about -1? Nope. All right, how about a half? Nope. -1/2? Nope. All right, a quarter? Nope. -1/4. Again, I'm only expecting 2 of these to work or so, but certainly no more than 4. Can't be more than 4. All right, so the first 6 are out of there. What's next? 3. Yeah, I got a feeling it's -3. Nope. Okay, well, I didn't know. 3/2, otherwise known as 1/2. -3/2. Okay. Well, tell you what I'm going to do here. I am going to grab the eraser and I'm going to get rid of some of the stuff that's in the way. We've already examined it and they don't work. Yay. All right. So we're at, we did 3/2. Okay, 3/4. So 3/4. Oh, wait, I got to click on this. 3/4. No. -3/4. No. 9. No. Ooh, that's not even close. -9. No. I'm starting to get a little nervous here. 4.5. 9/2. No. -4.5. No. Oh my gosh, there's only 2 left. 9/4. That's 2.25. 2.25. No. -2.25. No. So none of them work. That's not what I was expecting. Okay, so that would be what you do. So this function does not have any rational roots. It probably has roots, most likely. I mean, we can, x-intercepts. I guess we could just hit graph and say what happens. Oh, let's go zoom 6. Maybe we'll see it a little better. Yeah, okay, I see a root right there that's about -1, but apparently it's not quite -1. And one there at about 3, but 3 doesn't work, but it's really close to 3. So it does have at least 2 roots, okay, but they're not rational. That's okay. Now on this particular topic, all it said was use the theorem to make a list. So our answer is just going to be this list right here. They didn't say to actually use it. Okay. They will on, I think, the next one. Let's take a look. Okay, so on this one, we are going to find the roots. And it does say, it says, okay, this guy has at least one rational root, one rational zero, one rational x intercept. It says, use that to find all of them. Holy cow. All right, so let's get down to it, down and dirty. So my p's are going to be 1 and 2. That's what divides into the constant. My q's are going to be just 1 and 7. Oh man, we're working with prime numbers. This is wonderful, because then that means there's not as many choices. All right, so our p over q numbers are going to be 1 over 1, well, plus or minus 1 over 7, plus or minus 2 over 1, I'll just say 2, and plus or minus 2 over 7. All right, so now we'll plug the function into the calculator to see which of those work, because they know at least one of them works. On the last one, they didn't make sure of that, but this one, they're making sure. And that is why I paused the recording, because I wrote it wrong like 3 times. Okay, so let's go to the table. I'm going to hit delete a bunch of times. I'll get rid of everything in that list. Okay, so let's try them out. How about 1? No. -1. Yes, -1's a keeper. All right, I better write that down before I forget, because I know me. I'm really good at forgetting stuff. It's sort of my superpower. Okay, let's try another one. How about 1 divided by 7? Oh, I gotta click. No. How about -1 divided by 7? No. What's next? 2? Yaha! 2 works. Yeah, cut your throat. This is gonna work great. That's probably all it is. Okay. Usually, okay, so the highest power of x was 4. So we know that at most there are 4. Usually they give you enough. You get down to there being a couple. Okay. So this right here will get us down to a couple, but we'll check the rest. I mean, hey, if there's more, that would be great, and it wouldn't be hard to check. Okay, so -2 doesn't work. 2/7, no. -2/7, no. Okay, so just like we suspected. Okay, so -1 and 2, those are our guys. All right, so let's go. I don't know, yeah, that color there, I guess. All right, so because though -1 and 2 are zeros of the function, set the function equal to 0, those pop out. That means that x minus -1 and x minus 2 are a couple of factors. Okay, those are 2 of the factors. Well, guess what? We're not done. Okay, we still got to find the other 2. And we know they're not rational. They're not in that cool P over Q list we made. So how are we going to do this? Oh, and by the way, of course, this is, oh, I still got that on that mode. Minus, that's x plus 1. Okay, so if we were to divide these 2 factors into the polynomial, that would break the polynomial down. Just like saying, hey, for the number 64, or 64, 2 is a factor, I promise. Okay, and so if I divide the factor into it, it goes in 32 times, and I can say, oh yeah, the 64, kind of like the original function, can be written as one of its factors times the quotient. Well, that's all we're going to do by dividing these guys in, just like we divided the 2 in. Okay, and I got to make room. So we get to do polynomial division again. Hallelujah. Okay. So we're going to divide, let's start with x plus 1. So we'll divide that into 7x to the 4th minus 9x cubed. It's 13x squared plus, oh my gosh, I should have started higher up on the page. All right. So what do I multiply the first term by to get this first term? 7x cubed. So I multiply, I get 7x to the fourth plus 7x cubed. I subtract, and I get negative 16x cubed. Bring down the next term. Again, watch those subtractions. Multiply this thing by negative 16x squared. So that when I multiply negative 16x squared by the divisor, x plus 1, I get negative 16x cubed minus 16x squared. Then I subtract, and I get 3x squared. All right, bring down the next term, 5x. And I multiply by 3x and get 3x squared plus 3x. I subtract, and I get 2x. Now, because x plus 1 is a factor of this thing, okay, a rational, because it comes from the rational root, that means that the remainder should be 0. If it's not 0, then I've done something wrong. Okay, so I'll bring down the last term, plus 2, multiply by 2, I get 2x plus 2, and yeah, when I subtract, I get 0. Wow, I fit it all in there. Okay, so what does that tell us? That tells us that another factor is going to be, it tells us, sorry, I zoned out for a second. It tells us that the original function could be written as x plus 1 times that. And you could plug in your calculator, plug that into y1, plug those two into y2, multiply together, and go to the table. And yeah, you'll see that, yeah, they're the same thing. Okay, so we've broken this original polynomial down a bit to get that. Now we need to break it down by dividing by x plus 1. Now we need to break it down further by dividing by x minus 2. And I'm going to divide this guy, okay, by the x minus 2, not the original. If I do, then I'm kind of backtracking. Okay, so we got 7, negative 16, 3, 2. Okay, I just have to do some erasing here. Let's pause. Okay, so we're ready to do this. So we'll multiply by 7x squared, and we'll get minus 14x squared. Subtract, and that'll be negative 2x squared. And again, x minus 2 is a factor. Therefore, when we divide it in, it should give a remainder of 0, should divide evenly. All right, so then we'll multiply by minus 2x, I think. That looks good, I guess. And that'd be plus 4x. And then that'll be minus x. And the last thing, I'll multiply by negative 1. So they subtract is 0. All right, so it divided it evenly, so it's pretty much a guarantee I've done everything correctly. All right, so we've broken down the original polynomial to this guy times this guy times this guy. So we'll get 7x squared minus 2x minus 1. Okay, cool. Now let me erase the division. Okay, now remember the goal was find all the zeros. Well, we found 2 of them pretty quickly with the p over q stuff. And we've been working hard since then and not found more. But remember, we want to find the zeros of the function. Now notice, all 3 of our factors are either linear, highest power of x is 1, or quadratic, highest power of x is 2. We know how to work with those. Okay, so when I set this guy equal to 0, I get x equals negative 1. Yeah, we already knew about that. When I set this guy equal to 0, that factor equal to 0, I get x equals 2. Cool. When we set this guy equal to 0, it looks like stuff we've done many times in the past. Factoring, quadratic formula, completing the square, whatever you want. Now, we've already found all the rational zeros, so it's a good bet this is not going to factor nicely. So we probably want to just go straight to quadratic formula or completing the square either way. I'll go quadratic formula. So x is negative b plus or minus square root of b squared minus 4ac over 2a. All right, cool. And so we keep doing our thing. Let's see, we get a 4, we get a plus 28. Okay, cool. So 2 plus or minus root 32 over 14. Now, they're not going to want a decimal answer. If they're willing to accept a decimal answer, then we could have just gone straight to the graph and found the x-intercepts on the graph. Okay, so they don't want decimal. Now, can we simplify this guy any further? Yes, because we can factor out. Well, we can say, hey, that's 16 times 2, and I know the square root of 16. Whoops, that's 14, not 2. So square root of 16 is 4. And then we can cancel a 2 out of each term and get 1 plus or minus 2 root 2 over 7. And so that gives us our last two zeros. Okay, 1 plus 2 root 2 over 7 and 1 minus 2 root 2 over 7. And it's just that easy. What did that take? About an hour or so? But that's how you do it. It's a little bit lengthy, but that's the reality of it. Now you can check these guys to make sure they're okay. You can go to the graph, find all the zeros. These two will appear just like they do here because they're rational. These two will not, but you could plug these two into your calculator, get a decimal equivalent, and see if that matches up with what you get on your graph. So